आपस अभी ओपन तो नहीं किया है?
We, the Indian Society of
वेबिनार स्टार्ट कर दिया था सर मैं।
Heating, Refrigerating, and Air Conditioning Engineers, ISHRE, stands tall in the Indian industry with over 30,000 professionals and student members. Founded in 1981 and headquartered in Delhi, we operate from more than 50 chapters and sub-chapters spread all over India and members from across the world, expanding our horizon and bringing in our entire industry together. This vision has resulted in ISHRE growing internationally with the initial addition of 3 new overseas chapters at Bangladesh, UAE and Qatar. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRE disseminates knowledge through its technical committees, which consist of some of the best minds of our industry. It publishes technical books and a prestigious journal distributing a wealth of knowledge to all its members. Working with government departments, ISHRE helps formalize industry codes and standards. ISHRE promotes research by offering financial support to students members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRE Education Committee, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, Acrix India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interaction amongst the decision makers in the industry. Our chapters organize several other popular national events like AcreConf in Delhi, AcreTech in Bangalore, Recon in Kolkata, Symposia in Mumbai, TechFest in Goa, Confluence in Ahmedabad, ACR Trends in Pune, and many more. The chapters in India and overseas conduct theme-based national programs like Urja Varan, AcreServe, Pharma Connect and RAFCON. Cold chain industry is developing at a faster pace in India. ISHRE promotes refrigeration and cold chain by organizing South Asia's largest exhibition, Ref Cold India, exclusively for this sector every year in Indian cities, and ensures a platform for global investment and community to connect with stakeholders. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests, and site visits. eQuest, a prestigious quiz competition organized by ISHRE to catalyze the transformation of the budding engineering professionals. ISHRE provides a platform to potential employers to provide career placement to student members by ensuring the industry provides job opportunities on our web portal, the first of its kind, accessible to student members. A great opportunity for placements in the fast-growing HVACR industry with just a few clicks. Young minds are made aware of the need for saving energy, clean air, and sustainability through interaction with industry. The K-12 initiative of ISHRE focuses attention of school students' development to inculcate a scientific fervor and help develop them into responsible citizens. ISHRE collaborates with various national and international societies and associations, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection, energy efficiency and conservation, to enter and explore the universe of the Indian HVACR industry. Log on to ishre.in that unfolds a panorama of information. Let us engineer a sustainable future together through ISHRE.
Welcome to RefCold India 2025, South Asia's premier refrigeration and cold chain exhibition, an unparalleled platform where innovation meets opportunity. Experience the future of technology and innovation as global pioneers showcase groundbreaking advancements shaping the cold chain industry. RefCold offers a platform to explore advanced cold chain technologies across various sectors, including the food processing industry, pharma industry, transportation industry, last mile delivery services, hypermarkets, agriculture, horticulture, floriculture and energy efficient cold storage industries. At RefCold India, we foster powerful government connections, empowering policies and initiatives to revolutionize the refrigeration landscape. Discover a world of possibilities at the International Pavilion, where global collaborations take center stage. Strengthen your industry ties through B2B meetings and Association Connect programs, forging partnerships that drive progress. Expand your horizons with knowledge sessions led by industry experts and micro-influencers, sharing insights to inspire, inform, and empower growth for all. RefCold India champions MSMEs, providing an international platform for their innovations to shine.
As many of you know, RefCold is a very important platform for refrigeration and cold chain industry. This time it's going to be happening in New Delhi. New Delhi is, the real hotbed for technology players. So I'm really looking forward to RefCold 2025, and I hope each one of you watching this video would also join along with me in RefCold 2025.
The cold chain industry plays a crucial role in preserving food and material when they are not required for immediate consumption. However, we face significant challenges. To tackle these challenges and seize new opportunities, we are thrilled to announce RefCold 2025, which will take place from September 18th to 20th in 2025. The location is Bharat Mandapam.
In the present scenario of what is happening in the development of cold chain in India, and RefCold being Southeast Asia's largest exhibition, it is going to be of utter importance for the people and the stakeholders to know what NCCD is going to do and how NCCD is unfolding its new developmental plans in the development of cold chain in India.
Join us at RefCold India 2025, where the industry's biggest players, brightest minds, and boldest ideas converge. Be part of the revolution. See you in Delhi.
Good afternoon, everyone. Thank you all the panelists, speaker, and all the attendees joining for this refrigeration program. So without taking much of time, I request convener RefCold 2025, Mr. Ashish Gupta, to introduce with the speaker and proceed from here. Thank you, sir. Over to you.
Thank you, Tapas, and thank you, Pravin Mahajan ji, for being here today with us. And my gratitude to all the participants who have taken time out on a busy afternoon. I think it only speaks that we all are aligned towards more sustainable and more greener solutions, and to understand what in the processes that we do every day could be done better than before. So we are really happy to have you all here. I also take this opportunity to thank IPUA, which is the Indian Polyurethane Association, for coming jointly with us on the dais to share the latest in trends and technologies on the polyurethane, which is a very, very common thing that we all come to use in our refrigeration. So thank you, IPUA, and thank you, Praveen sir, for being here. Um, Praveen sir has 36 years of experience in chemical industry, and he's really held senior leadership positions at Bayer and BASF. Both we know are like leading German multinationals. He is a chemical engineer with postgraduate degree in polymers, and he holds extensive knowledge, and he has a leadership position in driving innovation and sustainable solutions. What we discussed with Mr. Mahajan was that we probably will do this program in a series of two, because to kindly deep dive into all the aspects in one session might not be possible. So I request all the audience to stay tuned whenever we have the next program coming, to join for the next program and the balance part of the program. Also, my personal request for all of the industry leaders to kindly block your date of 18th, 19th, and 20th of September for our RefCold, which is the premier expo, which is happening in New Delhi, Bharat Mandapam. This is the largest show that we know so far in terms of India, Indian subcontinent, and Middle East, and in and around Southeast Asia. We have the largest number of exhibitors. We have great 3 days of conference, and a huge government support in terms of all government ministries coming here, not only as endorsement, but also being here in terms of our sessions, in terms of exhibiting, and in terms of sharing their new and latest policies and guidelines, which will affect all of us. So with that, I will not take much away from the most prestigious time that you have accorded to Praveen sir. Thank you, Praveen sir, once again. And I would request the audience to keep on typing their questions and concerns, either in the chat box, or they can raise a hand. We will come to you. The session is meant to be interactive. All questions are important. There is no bad question. Maybe we could not be, हम लोग शायद कुछ नहीं आंसर कर पाएंगे. That's okay, but we'll come back to you with the right solution. But let's keep it interactive. Let's keep on learning. And my thank you to all and everybody. Thank you so much. Over to you, Praveen sir. Thank you so much.
Thank you, Ashwin Gupta ji. First of all, let me say a very thank you to Ishre also for giving us this opportunity for presenting on your platform. Looking at your entire presentation about Ishre and also the exhibition which is coming in the month of September, I think the topic which I'm going to talk a little bit on it, I think it suffices with that. And the way the cold chain industry is growing, and there's a lot of demand coming in. So I think this is a good collaboration between IPUA and ISHRE, and I think we will definitely help each other, and also to promote a lot of activities in the market with respect to the cold chain and cold chain activities. With that, let me also share my presentation. Can you able to see my screen?
Yes, sir. If you can go in the full, yeah, that's nice. Go ahead, sir.
Yeah, thank you. But just because we just spoken about the IPO, I will not go into much, but we have a lot of, we have almost 300 plus members, and we have a lot of activities to do, not only on the rigid foam, but also make in a different application as well. So what we do industry voices, basically, IPO activities, what we do we do industry voices, we do a policy advocacy, data knowledge creation, knowledge transfer and training. These are a lot of activities we are doing currently. And practically every quarter we have training happening on some or other subject, whether it is on slab stock or rigid foam or footwear or something of that sort. So I think that a lot of people who are there on this platform, if you're really interested in, please do join us for those training programs as well. So this is PUTech 2025. We just completed last week only. It's lot of almost 7,000 participant people visited this exhibition. We have almost 160 you can say booths, and you can see the people from across the industry like people also from the chemical supplier, manufacturer, traders, and all those people were present. So it was an amalgamation of all the people, and it really helped us for the industry to meet all the people together at one place. So now going to my topic, I would just like to say, okay, I will not say I'm the industry expert, but I would only say that I have a long experience in industry, specifically on the polyurethanes. So I would like to share my experiences as we go along with the slides. Uh, it will take roughly around 40-45 minutes for me to cover the entire presentation. And then we can, as Mr. Gupta said, that we can have a question and answer. I will try to answer the most of your questions as and when it comes. So just to give a little bit background about the history of polyurethanes, actually Dr. Otto Bayer, who discovered the polyurethane in 1937. His name is Otto Bayer, and he was working with the Bayer Germany. But in fact, he's not the owner of the company. He was working as a chemist in Bayer GmbH, and but he's the inventor of these particular things. And as the things go on, in 1940, rigid foam was first introduced in aircraft as an insulating material. And then 1941, it is adhesive for the rubber, metal, and glass. And this goes on and on. And in 2001, an automotive tires also being introduced based on a lot of innovation which has happened in polyurethanes. So I always say that a polyurethane is one of the most versatile product which can go to many applications, not into rigid, but in a flexible, semi-rigid, or even solid state. If I look at an entire variety of the polyurethane which goes into, it is basically, I would say it is divided into two. One is in the product which is in the form, and another is called as a solid. So some of the pictures you can see over here. But in foam also we can see that a flexible foam where we can make a block foam, molded foam, or even semi-rigid foam. Molded foam, typical example is the car seats or even furniture foam, which comes under the molded foam category. If rigid foam, when we also talk about a block foam or metal panel, we will see some of the slides later where I will also explain you what does this mean. Then insulating board and spray, where this is basically the spray foam is normally applicable where you already have the cold storages which is being made with a traditionally with cement mortar and use some inferior quality of insulating material. You wanted to refurbish that, then definitely you can use a spray foam for that. Integral skin foam, this is typically a product which has got a thicker skin on the top. So typical example of this integral skin foam is nothing but your steering wheel or the soft steering wheel which you see in the car, or even gear knobs, which is normally coming into high-end cars. These are all nothing but integral skin foam. In a solid state, in a rigid, you can say cast elastomer. Typical example is your caster wheels, which is normally, or the skate wheels, what you talk. So these are the one which we consider as a cast elastomers. Thermoplastic polyurethanes, a lot of thermoplastic polyurethane being used for making cables, or even if you look into some special products like mobile covers or even your watch straps and other things. Then PUR rubber, this is the malleable grade which can be milled as with normally being used for the rubber industry. In coatings, paints is a major sector. You look at today, the most of the car industry, the paint which is being used is all based upon a polyurethane coating. So you see the most of the companies today in India using PU paints. Textile leather, you see the artificial leathers are coming in the market in a big way. Majority of the artificial leathers are still based upon the plastic, like mainly in the PVC and other things. But nowadays with the new trend coming, which is based upon the polyurethanes, which has got a higher flexibility and durability point of view. You also see a lot of adhesives being manufactured based upon polyurethanes. In specialties, we have like fibers. So you must have heard the name called spandex, or the normally lot of lady jeans and a lot of trousers which is a little bit flexible when you stretch it. So this is nothing but all being based upon the spandex, which is based upon the polyurethane material. Gel, this is the new thing which is being introduced in the market, specifically if you're wearing a shoes for a very long time. So you always have a pain on your feet. So a lot of gelling material is being used into the pads, which give a lot of comfort and cool effect, and also in the medical applications. So why PU rigid foam is so good for? Basically it has got extremely good thermal insulation performance, and that's the reason why you look at today in most of the cold chain industry, predominantly the polyurethane foaming being used. This is just nothing. It has the cold structure. It has got a cold cell structure where the cells which contains the blowing agent as a gas after foaming. So that means the actual, if you look at an entire polymer chain, around 70 or you can say 60 to 65% of insulation you get it with the blowing agent which we entrap or you trap it into the cells. So more the gas you trap into the cells, you get the better thermal conductivity, thermal resistance to the material. So it's all depend on the kind of a formulation you make and also the kind of polyols or isocyanate you make to make the product much better. And as I already said, application like cold chain, cold storage warehouses, reefer container, then insulating trucks, refrigerators, all kind of, or even for the insulating buildings for all kind of a buildings where these materials are being used. You can see some of the pictures below, which clearly talked about using of the spray foam in the last picture. Let me just enter here. So this is a spray foam. You can see this is nothing but the asbestos sheets. And if you had got old warehouses and you wanted to have a good insulation performance there, then definitely you do not have to remove the entire asbestos sheets, but you have to only clean the surface and then spray the polyurethane foam on the top of it. So which is going to give you a better insulation performance. In this picture, you can see that this is nothing but using this board, polyurethane boards. So it is a typically in wooden houses, which is normally being used overseas. This is refrigerator, household refrigerators, what we use today. And these are the small cold storages, small or big, depends on the requirement of your requirements. So when I said this is PU is one of the best insulating material, there is a reason to it. Let's consider this as a diagram. So what this diagram says? If you take, say, suppose one, that means you can take 1 centimeter or 1 inch or whatever. So if you take 1 centimeter of the PU foam, then to get the same thermal properties, you need to have at least 2.2 centimeter of flexible foam or 2.2 centimeter of EPS, 2.25 centimeter of corkwood or fiberglass 2.55 or even wood 7 and concrete 16.4. So majority of our construction in India is based upon the cement and concrete. You can imagine the thermal insulation. It does not really give you a good thermal insulation at all. So what is really required is to have some kind of a thermal barrier on the top of it. That's why today most of the government organizations, they started using the insulating material on the wall and the roof to make the energy consumption on the lower side. Or also in case of woods, which normally being you typically see a cold countries like Canada or US, or if you go to even Japan and some part of even the China on the northern part of it, they are typically wood houses. But even the wood houses does not have the good thermal resistance or the thermal insulation compared to, but definitely it has got a better performance compared to concrete. So lot many people in across the globe, what they use is they make a wooden houses to some extent. Definitely they get an insulation performance, but on the top of it they also use a spray foam. So combination of the spray foam and the wood, that really gives you a good thermal resistance, and then you can see that their energy consumption drops down a lot because energy prices or the electricity prices in other part of the world are very high. So if you just take the same thing and other way, let's say if the thickness of all the materials are kept same, so what will happen? So if you take EPS, there will be a heat loss of around 42%. If you take a glass wool, which is around 56%, mineral wool will be 58%, cellular fiber will be 70%. You can then consider that. So if you just use the same thickness, which I already explained to you earlier, there will be a lot of thermal losses, which will definitely means you need a more energy to cool that area. So these are some of the pictures about different insulating material available in the market, and pick and choose will all depends on your final applications. But today, mostly the people have started using the rigid foam, polyurethane foam, just because the application is much faster. You can also do it with spray. You can use a panels or something of that sort. Handling other material like glass wool is very tedious. It also contains a lot of hazardous material when you use it, or it also penetrates to your body, and it also touches to your blood while installation. So there are a lot of drawbacks with a lot of other materials, which also makes it difficult and to use this product, and the consumption also started dropping it for a period of time. So when you talk about rigid foam, Basically, this is nothing but, how do you really make a rigid foam is what you need is a polyol and isocyanates. So if you typically take any formulation, it ranges from around 90 to 95% is around polyol and isocyanate, and around, you can say, 5 to 10% will other ingredients like catalyst, surfactant, blowing agents, and fire retardant, all the stuff which is being added. When we say catalyst, that means it is something like, when we are driving the automatic car. If you just start a car and release your the brake, it start moving with a speed maybe around 10 to 20 kilometer per hour. But what you need, if you really need to go faster, you need to put a throttle on the engine. That means you are accelerating it. It is exactly the same phenomenon the catalyst does. So when you are trying to make any product out of the making a ISO and polyol to make a rigid foam or any other product, you need to add a catalyst to really accelerate the reaction so that your final product can be made quickly. Similarly, for the surfactant as well, when you are trying to make a foam, you also get a lot of bubbles, which you can say in the below screen here. So these are all nothing but this is sales. So to have a good sales and a stable sales, otherwise, if you do not give a surfactant to it, the automatically sales will collapse, and then you are not going to get a foam. So it is very similar. You must have seen in our houses also. We use a lot of detergent for washing our clothes. So what actually happens is when you take a detergent and put it in the water and just stir it, or maybe हम लोग बोलते हैं खंगालना, अगर आप वो करोगे तो you get a lot of foam on the top of the water. But if you just wait for 1 minute or even less than 1 minute, the entire foaming really goes down or it completely vanishes. Why? Because it's a surfactant. When you are using a very little or very weak surfactant, it does not give you stability to the bubbles. But exactly an opposite, which what we do in rigid chemistry or the polyurethane chemistry, that apart from the catalyst, we have to also use the surfactant to make our cell structure more stable. Third point, which talked about blowing agent, which I already mentioned to you. The blowing agent, there are two different blowing agent. One is called as a physical blowing agent, another is called as a chemical blowing agent. But majority, what we use, a very good amount of blowing agent we use, which really gives you really good thermal conductivity. And we will discuss more in detail in our next series. And also the fire retardant, which is nowadays, looking at so many accidents happened in the past, also not only India, but across the globe. So everybody is looking for a better fire performing materials. So by addition of some fire retardant into the formulation, you can improve the product fire performance as well. And then typically you can see this is glow cells, and this particular slide is just showing about the cross-link structure. That means if you look at here in this particular thing, this is specifically I'm talking about rigid foam. That's why you see that the cross-links of structures is very close. These cross-links are very close. That's the reason why you can see this is a very compact structure. But if you just take this one for the flexible foam, then you will see a one cross-link here, another cross-link is here. There will not be cross-link in between, because there our requirement is different. Like when you are sitting on the car seat, you require to have a breathing to happen. That means there should be a flexibility to the foam so that there is a fresh air every time coming and going. So you get more comfort to you rather than giving discomfort. So that's the reason, all technologies depend upon what kind of a formulation, what kind of a polyol isocyanates you use to make the structure, cross-link structure, whether you wanted to have a flexible one or rigid one. So this is a basic typical foaming or reaction profile. This is basically to give you kind of an understanding. And these are the typical diagram for the hand foaming or hand mixing, you can say. So here what actually happens, all the components, when you talk about the iso polyol, everything comes in the liquid form. And all the ingredients, that means the catalyst, surfactant, additives, and blowing agent, everything what you do is you add it into polyol and you keep isocyanate separate. Finally, when the mixture of the polyol is ready, blend is ready, then you actually take, this is the diagram which is being shown. This is your isocyanate, which is component B. This is the polyol, which contains all the ingredients put together, including polyol. They are put into the beaker, and this is a stirrer where do the homogenizing of both the mixtures together. As soon as you homogenize the material, you will see there is an exothermic reaction starts. So that is the reason when you do any kind of reaction, whether you do it on the machine or the hand foaming, the iso and polyol temperature has always been kept between 20 to 23. so that the reaction should not be too fast, and then controlling the reaction will be difficult. So this is the normal temperature we have to maintain, whether in a larger plant where you really going to make a lot of products, or you are also going to make in the laboratory form for the initial development as well. So as soon as what happens, as soon as you make the temperature of initial iso and polyol was somewhere around 22, let's say. Within 1 minute, as this is an exothermic reaction, within a minute, the temperature of these components really goes more than 100. So you can understand the kind of exotherm it has got. And everything can depend on the exotherm or the kind of a formulation you make. So we have also had a lot of accidents within the country for making this mattress foam, because if your formulations are not right, if your exotherms are very high, and it is also been proven, if your exothermic reaction is faster, higher, and if the temperature of the exotherm reaches to 160 and above, 160 to 65 and above, then you start getting charring, or sometimes you also start getting a fire. And that's why we have so many accidents in the past, not only in India, across the globe. So making a right formulation, keeping the right processing temperature, also very, very important while designing the formulation as such. So this is how the foam really start rising, is still rising, and then you get a gelling of it, but it is still stacky. And then you can see the phenomena which happens. And then once you reach to the maximum, then you get the foam does not rise further. And then if you touch this particular surface, this will be dry. There will not be tackiness. That means it is called as a tack-free time. So that means the product is now fully blown and does not have, if you just remove this particular product, maybe in a span of 1 minute, you will see this is a really hard in case of rigid foam. So this is a typical diagram for the machine. If you really wanted to make a larger component, so there is a two tanks basically. One is called the polyol tank, one is called the isocyanate tank, which you can see here, isocyanate and polyol. These are basically the metering pump. So this is the metering pump over here, and which really whatever the volume which is required for you to fill up the mold, depending upon that, you are giving the command to the metering pump in A and B component, like polyol and iso component. So automatically what happens is that it precisely gives you a product of a similar weight. Let's say if you wanted to have 600 grams of polyol and 50 grams of isocyanate, then 100 grams of polyol being pumped by metering pump in and goes into the mixture, and isocyanate 50 grams come from the another metering pump, and it is vigorously getting mixed, and it is being poured as soon as you take a shot. And this is what yellow line you see. This is how the material initially it becomes, and then we start rising and fill the whole entire cavity. This is how the process is all about. So whether it's a small, big, and all these machines, they have a different capabilities machine available in the market depending upon the final product volume which you wanted to make. So this is all is available today, and metering is precise. You can also have you can say the processing machines which are called the low pressure machine, which is called also high pressure machines. Normally, low pressure machine is low cost investment, does not have the you can say the where the iso and polyol are mixed with a stirrer. So you really do not get a very high quality of mixing of iso and polyol. So you have a lot of chance of getting a little bit inferior quality, or ever air bubbles could be also one of the possibility when you make a final foam. But when you are using high pressure machine, where the injection is in opened up and the more the materials are almost being mixed at 120 bar, then it is something like which is a fantastic mixing which happens in the mixed before it materials gets poured. So you get much more final sales. You get very high amount of entrapment of the gases inside, and the quality of materials become very uniform, and reproducibility of the results are also very good. So some of the applications I would like to talk here is that one product I would cite was a continuous panel. So these are the material which normally being very predominantly being used today, as I mentioned, also in a cold chain or the bigger warehouses also. This is where the product is being continuously produced. You can see over here, this is a continuous line. There is you do not see, because this is continuous way it is being produced, and this is how the material comes out of it. And whatever the length you require, or whatever the thickness you require, you can really do as per your requirement. You can make any kind of a panels. You can, if you wanted to make a 40 mm, even 20 mm, 40, 60, 80 or 100, or even you can go up to 240 thick panels. And you can also have a required width about 1 meter to 1.2 meters. You can really make. And then once you have given a command to the computer, you can really make the panels of the required length. So here, as I mentioned, these are basically an high pressure machine being used over here. So you have a very better cell structure you get, high quality and accuracy you get, high productivity because this is a continuous lines process, and easy extension of or dismantling of the building. So this is, if I really look into, if I just give you an example, if you really wanted to make any warehouse, let's say if it is 2000 square meter warehouse, if you wanted to make it a traditional building, traditional material like cement and concrete, it will take around maybe 4 5 months for you to complete, even if you do it on the war footing. But if you really wanted to make the building with a sandwich panel, you can really make even 2000 square meter panel maybe in a week time. So this is the beauty of using a panel when you really wanted to make a larger warehouses or even cold storage there. There is another process called the disconti process. Here, it is exactly the opposite to that. In continuous line, you can produce the length as you, and you can cut the panels as per your requirement. But here, the length is fixed. So you can either produce 2 meter, 4, 6, 8, 10, a maximum you can make it around 12 meters. So 12 meters is the maximum length of the panel which we can produce in Disconti panel. Thickness, definitely you can go from low to thigh, but not to 240, but around 200 you can really easily able to produce it. Here the only advantage is if you can also make little bit higher width compared to the continuous line. That is the only thing. And which I already mentioned, this is customized. Even if suppose if you wanted to make only 1 meter, even 3 meters, which is so it is possible to do it. Normally doors, fixtures, when you want to do, when you look at the cold storage door or the cold chain doors, which possibly is required, it also has some glass windows and all. Possibly you will not able to do with the continuous line process, but this continuous line definitely help you to make such kind of doors easily. And then entirely, if you look at if you look at the total investment for such kind of a project is much lower compared to the continuous line. But if you will eventually look at from last 3 4 years, most of this discontinuous line now is switching over to the continuous line because demand for the cold storages and warehouses has gone up. It does not mean that every time lot of material which is being imported now required to have a lot of temperature control inside the warehouses. So the demand for the warehouses and the cold storage has really gone up over a period of time. And if I really look into, as per my understanding from the market, today this market is roughly around growing around 10 to 11% on CAGR. So you can see that the really demand for the sandwich panels are really going up. So which just I just mentioned to you, Disconti panels, yes, this is you can produce it with high as well as low pressure machine. Panel width length is 1 meter to maybe 12 meters. Width you can go up to 0.5 to 2.5 meters. Foam thickness around 50 to 200 Typical density is around 38 to 45. But in case of continuous panels, you have to only use a high pressure machine. Panel length is unlimited. All depends on your final requirements. Width, you can maximum go up to 1 to 1.2 meters as compared to 2.5 to 2.5 meters. Typical thickness, you can up to go to 100 to 240 millimeters. And density, definitely going to get it lower density. Does not mean that you cannot produce high density, but eventually you get a much lower density compared to a discontinuous panel. So these are some of the pictures I wanted to show. Cold chain, you must have already seen, some of the people already on this forum must have seen cold storages. You can also use the cold storages, or if refer containers, refrigerator trucks. All these panels are being used right now. Again, the choice of the thickness all depends on your final the product requirement. If say suppose if you are talking about the Apple cold storages, which is more perishable, you need to really distribute to a longer distance. You need to have better storage stability of those products, which also breathes a lot, and you get a lot of carbon dioxide when the apples get aged over a period of time. Definitely, then you need to have a thicker panels. Maybe you will use maybe 150, maybe 200 or whatever. So all depends. If you look at the potato cold storages, Potato culture does not really require to have a very high thermal insulation. Even a lot of people they can use around 40 mm or 60 mm of panel will be also good enough for them. So this is basically what it is. Then you can also in building construction, so definitely you can have molded boxes, sheds, garage, and residential houses. In India, I would say that residential houses basically people mostly prefer to have insulation from the inner wall rather than outside wall. But specifically in outside country, people prefer to have it from the outer wall rather than inner wall. So this is again typical block form or the pipe insulation. So here you can see this is the box. This is a fixed dimension box, maybe 1 meter by 1 meter box, where you can inject the isopolyol formulation and it automatically rises. It has got a small lid on the top so that it really compresses and give exactly the width of 1 meter by 1 meter. This is a low cost process. If you really do not have a very high requirements, one can also go with this kind of a process. Once you make a block, once it gets aged completely, normally when you make a foam, you always have to keep it for 24 hours to reaction to complete. Once you do that, then as per your thickness requirement, you can slice it. You can see here different slices. Over here also you can see you can make the slice of 20 mm, 40, 60, depending upon final end use applications. Second, this is another application with pipe insulation. This is very common in colder countries. If you go to like Japan, China, Korea, or in Europe, where they also talked about a district heating, heating, where they do transfer a lot of hot water from one place to another place. So in India, we do not have that challenge. Mostly, what we use it is for very typical applications. And if I remember correctly, I was also involved in one of the project, so where we completed transferring the crude oil for Reliance refinery from Jamnagar to the you can say in the northern place, so which is around 610 kilometers. So you have to really make a big pipes, and which you can see over here, this kind of a pipe which is insulated. But there are two ways of doing it. This is you can make it two halves, and then you can assemble it, and then you can use some kind of aluminum cladding to make a final pipe. But especially for the oil transport, the crude transport material, you really cannot do it. You have to spray it. Your metal pipe is rotating and it is being sprayed. Once it is being sprayed, then you have to use an LDP or HDP jacketing on the top of it, which is also being done automatically. And then the pipe being transported, and then this particular portion are welded, and the welding joints are being again formed at the site locations. So these are the different applications of the pipe as well. This is what we already using it in our own houses every day. For the refrigerators, all the refrigerators, if you look at today, is being insulated with PU 100%. Nobody uses any other insulating material because the requirement for the cold storage or specifically for deep freezer and everything is much higher, lower. That means the temperature require -10, -15 or something. So definitely you need to have a good thermal insulating materials like PU. You can see here typical refrigerators or VC coolers. These are deep freezers or even deep freezers. All these products are nothing but all insulated with PU foam because you require to have faster processing, energy efficiency, then flowability. You can have intricate design nowadays. You can see here that if you really open up the refrigerator, you will see there are a lot of ribs in between where you can just keep a parts trays like a glass trays or even the plastic trays. You keep it, but to really get a best performance, you need to also have that ribs to be also filled. And the best part of in polyurethane is that since it is being injected in the liquid form, the liquid can really flow through, not only in the entire cavity, also to the ribs. So it gets completely filled up. And then your insulation performance become fast better. Similarly, also you can see here, this is the product which is called the water heater. Earlier, we used to have only water based upon using a glass wool or mineral wool was the typical usages for heater. But nowadays, you need to have very high productivity. Here, you can just have a two cavities. You can make your inner body, outer body, and just keep a gap in between and take an injection. or you can take a shot of IPUA and polyol in between. The entire cavity gets filled up. It is have got a fantastic adhesion between the two walls, so there is no, you can say, the gap in between. So thermal insulation performance will be much better when you have a very adhesion, very good adhesion between the two substrate. Similarly, this is also the typical example nowadays. A lot of people started using the solar heater, and this is a typical solar heater tank. So when you have a sun in the morning or even daytime, or specifically I would say in the winter season, you have got a sun only maybe a couple of hours. So water gets heated up and being stored into this. And once it's stored, you need to have really good insulation so that your water temperature remains for a long time. So you must have seen even today, a lot of residential buildings who has already installed these solar heaters. You also start getting the heating water in the afternoon as well, or even in the evening as well, because they are really put up a big storage tank, which is very well insulated with a rigid foam, so that the thermal losses are much lower. This is again a very specialized applications. This is my last slide. This is basically between the two cavities. This is called a in situ foaming. Or the in situ foaming is being very commonly used specifically for, you can say, the beer manufacturing industries, because when the beers are being produced, it is being produced and stored in a larger tanks, which could be of the size of around 5 to 6 or 7 meters height. So and you need to really keep it at a very prescribed temperature or specified temperature. So you need to have very nice insulating product there. So when you are taking the injection shot here, you can see this is the two cavities over here. This is the outer cavity, this is the inner cavity. The entire foam is rising and filling up the entire cavity. So the adhesion between these two cavities is also good. So you can really store your beer before it is being bottled or canned and go to the customer. So this is a typical application of in situ foaming. Also a lot of buoyants, which is normally being used in the sea for guiding the ships, which is also around, you can say, 3 to 4, 5 meters of width and length of around 1 to 2 meters or 2 to 4 meters. So they are also been injected with the rigid foam so that it can float and also guide the larger ships. This is another application. Is called the packaging foam. When you want to do transport your very valued, high value products over a longer distance within the country or outside country, then what you can do is you can just take a few shot within a box and keep your material, and then take another shot, so the entire shape of the you can say your product gets covered up with the rigid foam or the semi-rigid foam, and the transportation becomes easy, and also the chances of damages happening over a period of time or during the transportation is absolutely bare minimum. This again AHU panel, where you see a lot of energy, or you can say there's a lot of noise also coming. Also, you need to have you can say the thermal barrier. So all these are the panels, small panels over here. These are all panels are insulated with a PU foam, which may not be very thick. People use it maybe around 20 to 30 panel, but really helps us in AHU unit. Last but not the least, this is a common thermoware which are being used in our household, whether it is a water bottle, or maybe thermoware keeping or ice boxes. All those products are also been with the use of rigid foam in between this. If you look at this green and an outer pink, there is a gap in between these two. So this green is actually being fixed later. So you have the you can say the pink color container which has got a cavity, where you take a shot, and then once the material is completely filled up, then you just you fix up the top green color, you can say the cover, and then entire process is ready. Same thing also for other material as well. This also had a very large requirement over a period of time from last 3 4 years. For, you must have seen during the COVID time, or even when you are exporting a lot of medicines which really need to have a very large temperature control, or from one country to another country, there are a lot of boxes which is being insulated and being used for such kind of applications. So people use a very good amount of foam there, very high insulating foam, so that when it reaches from India to US or for any other country, so your material or medicine can really reach those places without any issues or without changing any configuration of the material. So this is a little bit about the I would say the my today's presentation. Next week we will talk about the different blowing agent. We also talk about what are the environmental impact of the blowing agent, how the ozone layer was being damaged, what was the reason for damaging the ozone layer, why the global warming is really taking place. We also talk about the fire performances requirements in the industry today. So these are the topics we will cover up in a second session. So thank you, and I hope that you liked what I just mentioned. If anybody has any questions, I am happy to take it up.
Thank you, sir. Thank you very much. And it was a great learning session, I would say. We have received many of the questions in chat box and Q&A. That shows that how much audience are involved in this presentation. I request Kohli sir. Kohli sir is with us. He is the Refrigeration Chair of Delhi Chapter of ISRE. I request Sandeep Kohli sir to uh, uh, go ahead for the question answer session.
Yeah.
Thank
So
you.
thanks,
Over to you, sir.
Tapas.
Yeah.
Thanks, Tapas, and great seminar, webinar, basically by Pravin Mahajan ji. Really, like the complete webinar. There's so much to learn. Being in the HU industry, we keep on using the puff panels, but there was a lot of things which were eye openers for us. So now we have couple of questions in the chat box, and the Q&A also. I think there are some questions, so we can take them one by one. So I think first question, Parveen ji, is from Ankush Salvi. He's asking what are the differences in reactivity profile and formulations for discontinuous, continuous, and thermoware applications. So
first of all, you also need to understand there are a few things I would like to explain. First of all, what you need is if you wanted to make a large panel like 12 meters, so then you need to have a machine which can deliver a large, or you can say the sizable amount of material. Because to fill up that entire volume of 12 meter, you need to have a machine which can give a higher throughput to fill up the entire cavity. So it all depends. And once suppose if you have a larger machine, then you also need to understand what is the time required to fill up those. So you have to fill up as fast as possible, but then everything depends on how much is the throughput of the machine, and then you can derive the formulation accordingly. So it all depends on the kind of a machine what you have and what kind of a size of the panels, maximum size of the panels you wanted to produce. And then formulating for the discontinuous panel is not an issue. Okay. In continuous line, you do not have really much challenge because there is continuous line is nothing but you have a polyol isocyanate and catalyst, everything is online. So whenever you wanted to change the thickness, you wanted to change the speed, because everything depends on machine. So you have an expertise, the person or the operator who is operating there, he knows what catalyst to be charged to make such a thickness, or the lower down the thickness, higher down the thickness. So he adjusts the no, the dosing of those catalysts and also polyol isocyanate accordingly. So this is how the formulations are being made depending upon the thickness, whether it is a continuous line or discontinuous line.
thanks, Parvinji. The next question is from Mr. Sharad Malga. So he's asking, what about nitrile rubber with respect to thermal conductivity?
So nitrile rubber thermal, if I just ballpark figure, if I tell, let's say what as far as my understanding goes, PU foam will give you a thermal conductivity of 0.02, let's say. Yeah. Again, it depends on how fast reactivity you have. So now the people are even talking about, now there is a new technology which is coming up, which is called the VIP, vacuum insulating panels. So if you really make up vacuum insulated panels, you can get a thermal conductivity of even 4 or 5, which is never been heard of. So, but if I look at typically nitrile rubber, which is somewhere around 0.03. So you can see there's a huge difference. Only advantage with nitrile rubber is that it is only a flexible. That's why a lot of people they prefer, specifically for the smaller. Like if you look into the air condition which are being installed in houses. So when you have a copper tubing coming from your main unit to your actual box. So for those applications, people use nitrile rubber or maybe some other applications as well. But it is, if you really wanted to look into a really energy saving thermal conductivity, then I would say the rigid foam is the best out of all.
Okay, thank you. So there is one more question in the webinar chat by Mr. Tamil Selvan. He's asking, what is the main difference between polyester and polyether polyols for rigid application, and which polyol is good?
See, I would not say good or bad. Whether polyether is also good, polyester is also good. Yeah. But only thing that in just as a just to give an information, normally the polyester which you get a bare fire performance, okay, compared to polyether. But usually today, if you look at panels are also being made with PUR and PIR, okay, polyurethane panels and polyisosilurate panels. So lot many people, when they make a PIR panel, they use a combination of PU or PIR, or sometimes you use a larger amount of the PUR or polyether and polyester. So again, the technology will depend from the company to company. You may also use it a very high amount of polyester and slightly lower amount of polyether there, but it is all depends on that. So it is a combination of polyester and polyether. I would not say which is good or bad, but normally polyester you need to have a slightly higher temperature for manufacturing. So normally people prefer to have a polyester combination or even 100% polyester for the Conti line. For disconti line, majority of the people they use higher amount of PUR or the polyether.
Okay, thanks. And there are few more questions, Pravinji. So the next question is from Mr. Deepak Sharma. He's asking, are we using same insulation for cooling and heating? Means for the refrigerator and heat pump, do we use the same insulation? I think he's asking about a puff only. So if it is a refrigerator and if it is a heat pump, so do we use the same thing, or there is some difference when it is heating and cooling?
The refrigerator, which I already explained, it is yes. I do not have any heat pump, at least I have no idea. But if they are already using it, which is a rigid in nature, definitely it must be then rigid foam. Yeah. So that's my understanding.
I would like to rephrase the question as I understand. So maybe he's asking, if we are trying to save the cooling energy, like in refrigerator, is the insulation same in the case we are trying to save the heating energy? Maybe some
Yeah. See, understood. So if I understand the question correctly, look into it that we are in a tropical countries in India like now. Our outside temperature is hot. What we need is cool inside. So we use a lot of air conditioning to cool down our inner houses. Yeah. If you go to Europe or if you go to the colder countries, outside temperature is cold. So their temperature is -2, -10, -15, maybe whatever.
Right.
And what they need a heating inside.
Mm.
So that's why I also mentioned right in the beginning, normally in other part of the world, what people do is they use a insulation inside.
Mm.
And in India, because we do not want our walls to get heat up, so what we use a insulation from the outside. So this should be the criteria. I'm not saying that we do not use it from inside, but if somebody give me a choice, I'll always prefer to have the panels being used from the outer side rather than inside. Yeah. But the phenomena is the same. It is all only whether you need to do a cooling part or you need to do a heating part within the envelope.
Okay. Another question is from Mr. Devinder. He is asking, what are FR standards in the rigid industry? Does it vary as per different applications?
No, there is no much difference in the industry. If you look at a BI standard, they have a typical standards available. Okay. They talked about what is the thermal conductivity required for the rigid foam, what should be the compressive strength, what should be the you can say the adhesion strength, what should be the tensile properties, what is the density. So they are given some range. So you need to fall within that range to to meet. But there are certain companies, like if you look at some of the consultant, they may ask you some specific requirements, especially in terms of fire. Yeah. So there are certain agency, they will ask you, oh, no, I wanted to have fire resistance so much. So there are then different standard which we being used globally. Yeah. So you need to get aligned yourself. You need to develop your material in such a way that it passes to that standard. So that's how the different standards are available.
But if he wants, he can get the fire resistance standards for rigid industry from some source. Is it possible to down?
Yes. Yeah, it's already that there are two standards available in the from the BIS. Currently, I am working on making the one single standard instead of two. So which we recently I will have maybe in a 15 to 20 days time, I will have a meeting with an BIS people to explain them why we want to do a single one. And then because if I look at both the standard, there is a little bit confusion here and there. So I just wanted to get their, talk to them, understand their viewpoint. I also wanted to explain my viewpoint so that, it will benefit to the industry rather than having a multiple standards. Let's have one common standard and then we can add on the top of it.
Okay, but these two standards are readily available to be downloaded from BIS website
Yes. It is available
free
on
of cost?
Yeah, it is a free of cost.
Okay, one last question because we are already touched 4 p.m. Although there are questions and it's being interactive, but we will to honor the time and for everyone. Let's have one last question from one anonymous attendee. But the question is good. What is insulation resistance, thickness, and density you will recommend for lead sustainability projects for both wall and roof?
This is a very typical question. See, the lead, there is a point system, right? If I understand correctly. So maybe, for silver rating, gold rating, or platinum rating, you need to comply to the points. Okay. So there are a lot of criteria for that. So what you can do, you can have maybe, you can say the sunlight will be coming from the top. So you try to require to use too much of light inside and all those stuff. Based upon that, you get a different point system to meet the rating as per the silver, gold, or platinum, whatever. So insulation, yes, definitely. Insulation also, if you are looking it into the entire project, if you think that this particular project required to have, let's say if it is IT companies, which is using 24/7 and air conditioning. So they require to have a lot of energy to really maintain the temperature within the total envelope. And if it is area, like if it is let's say it is Infosys, they have a very large, you can say the office building. So definitely, then if you look at that, those criteria, then you can decide what thickness you want. So if you use a thicker, maybe then definitely you're going to get a requirement of energy will be less. But again, it all depends on your costings and everything put together. But that will give you ultimately the point systems, how much energy you can save from the PU perspective, from the insulation perspective. But there are some other points as well, which also takes care, which will be talked into the lead systems.
Thank you, Mr. Mahajan. I think it was a wonderful seminar, webinar, basically with a lot of questions. There may be some question answer I request. Almost more than 50 people were there in the attendance. So I will request those people to get in touch with Ishre, Mr. Tapas, and some people were asking your mobile number and email ID, but I think it will be better if they get in touch with Tapas, Ishre, our end, and he shares to wherever. Some people were asking for the PPT copy also. That also you and I think Ishre people can discuss and do the needful. And myself, I am basically having industry experience of more than 28 years in HVAC in our industry, but this is one of the best webinars that I've attended, a lot of knowledge, and you have shared it also very openly. And looking forward to your next webinar in coming weeks. Thank you so much once again, Pravin Mahajanji. It was wonderful to have you on this Ishre platform. We are glad that you spared this time and shared your valuable knowledge with all of us. Thank you so much.
It was really my pleasure. I also look forward to the second session as well. Thank you once again. Thank you very much, Ishre, and entire management of Ishre also giving me this opportunity. I look forward to have maybe sometime if I am in Delhi, possibly we can meet in person.
Sure.
We can take it forward. Anyway, I'll see tomorrow. Are you coming for this India cooling enclave?
I'm not sure. Let me check. Let me check my schedule.
Let's see, because tomorrow I will be in Delhi. So if we can able to meet there, let's see. We can catch up each other. Yeah.
Sure. Thank
you very much. Thanks
again,
once again.
Thank you.
Thank you.
Thank you, everybody. With your permission, should I close the webinar then?
Yes, Tapas, you can close the webinar. Thank you.
Okay, sir.
Thank
Thank you
you.
very much. Thank you, sir. Thank you. Bye.